3 is quite a bit different. Ultimately, it still will come down to Pivnert. All right, we're solving for moles. So if PV equals nRT, then N will be equal to PV over RT. So this is the equation we're eventually going to use to figure this out. And it's not that bad, but just a couple of things we have to do before we get there. All right, room temperature and pressure. All right, this is also considered STP, which stands for standard temperature and pressure. I expect that you've read that in your book and that you now know that standard temperature is 25 degrees Celsius and standard pressure is 1 atm. They'll use that a lot. Now, we need this to become a Kelvin to use it correctly with R. So we don't just change it to a K, we add 273. So this now becomes 298 Kelvin and 1 atm. All right? So we have the volume right here. That needs to be in liters. All right? So 0.254 liters of hydrogen gas is given off. All right, so here we go. 254 milliliters of hydrogen gas was collected over water at STP. How many moles of Mg must have been reacted with hydrochloric acid to produce this volume of gas? All right, you'll notice hydrogen and Mg are not the same thing, so we also have to involve chemistry in this by writing out a balanced equation. All right, it says magnesium is reacted with hydrochloric acid, so we have Mg plus HCl goes to MgCl2 plus H2. Now, we have to obey stoichiometry here, so we have to balance the reaction. There's 2 H's, 2 Cl's, so I got to put 2 right here. Everything else is just a 1. All right, so when we solve this, it won't be that bad because the Mg and the H2 have the same coefficient. All right, the final thing that we need to worry about is this new part of this problem. It says the vapor pressure of water at room temperature is 22.77 torr. All right, now, to explain why this is important is because if I have a flask that this reaction's happening in, and we're going to cork it because we're now talking about gas loss, so it has to, it doesn't have to be corked, but whatever, just pretend it is. All right, we have HCl here. And when this reacts, if it's in hydrochloric acid, you can't have hydrochloric acid unless it's placed in water. All right, now, having water present makes things a little bit tricky because water itself is a liquid, but at every temperature, some of the water is actually gas. All right, it's a small percentage, but some of this has evaporated and is now here. Now, this measurement we call the vapor pressure, or it's the part of the vapor, like the gas, that is water. Now, we have to account for that because if water is in the gas, but we only want to know H2, we have to subtract out the amount of water. So in the problem we're talking about, it says that the pressure is 1 atm. 1 atm of pressure, it's the pressure of the H2 that we want to know about, plus the pressure of the H2O, which is the vapor pressure. Now, this can be pretty simple, but we have to convert it to torr because this problem, it gave it to me in torr. So 22.77, we have to convert the torr to atm. I said that a little bit wrong. So we take 22.77 torr, and we just divide it by 760 torr. The reason we do that is because for every 1 atm, we have 760 torr. or millimeters of mercury. All right, when I type this in, let me pause. When I type this in, I got this number 0.02996, and that's ATM now, because that was why I converted it. This is the amount of pressure that is H2O. So what I'm going to do, I'm going to take 1 ATM, which is my total, and I'm going to subtract 0.02996. That's supposed to be a 6. And then I get that. And I get 0.97003. So we'll just call this 0.97 ATM. And that is the pressure of just the H2. So now I'm going to come back. I already forgot that number, 0.97. And I'm ready to roll. So N will be equal to 0.97 ATM. That's the pressure of just the H. Times my volume of it, which is 0.254 liters, over R, which is 0.0821. All right, now this is really 0.08206, but I round it here. If you see it in the book as 0.08206, don't panic, it's the same thing. All right, and then T we converted to 298K. I'm going to plug all that in. 0.1 N, so that's moles. All right, now that's moles of H2, but this is asking how many moles of Mg. But remember, it's the same because they have the same coefficient. So how many moles of Mg must be reacted? The answer overall is 0.01 moles of Mg. Now, typically, this problem asks you to answer in grams. So if it asked for grams, you would just multiply this now by the molar mass of 24, and you get 0.24 grams of Mg. All right, but it didn't ask for that, so 0.01 is our answer.